Okay, here we go. Unit test review. We have the fourth root of 1,250 x to the 7th y to the 16th, and it's our job to simplify it. Okay, so there's no adding or subtracting, so we're going to apply the properties of exponent rules and make your lines as you do it. Now, do you have a radical? You do. So first thing, before I start on the lines, we're going to make that a quantity to the 1/4 power, and then we just put the inside 1,250 x to the 7th y to the 16th. So we have 1,250 times x times y. Now we figure out what the exponents are. So we got a 1 times 1/4 is 1/4. 7 times 1/4 gives me 1 3/4. Remember to use your calculator if you're not a fraction whiz. And then y, 16 times 1/4 is 4 whole. That right there is 1 3/4. 1 3/4. Okay. Now, none of these are negatives, so they all just stay in the same place. Okay. Okay, now I circle what I have for the whole exponents. So that would be the 1 and the 4, so it would be x1 and y4. Now I write my fractions, 1/4 and 3/4. So we have a base of 1,250 to the 1/4 power, and then an x to the 3/4 power. Now circle the bottoms on those fractions, not here though. Alright, so that's a whole, okay? These are 4s on bottom, so you look at your 4 list and see if you can get rid of the bottom quickly. Well, 1,250 is not here, neither is x, so we can't, they stay for now, okay? Now, do we have any exponent, do we have any fractions, do we even have any bases on bottom? No, we don't, okay? Now, it's time to get rid of those 4s on bottom by making them into radicals. Now, these are wholes, so the whole exponents just hang out, x to the 1 times y to the 4. Then the fractions, they're both the same, so we make them into one single 4th root, and now we can take them off. But I still have 1,250 to the 1st power times x to the 3 power. Now it's time to do the final simplifying. So x to the 1 stays the same, y to the 3rd stays the same, and then we make the 4th root. Now circle any base numbers you have. That would be the 250 to the 1 power. The x3rd just goes inside there. Now I circled that because I have to now simplify it, or at least try. So 1,250 to the 1st is 1,250. Then I try to break it down into 2 different radicals. So on your 4 list, you start at 625. And that works, so I rewrite that as 625 times 2, and then 625 is equal to 5, okay? So the 5 comes out, and that 2 stays in the radical. Simplified. Okay, number 2, we have the 3rd root of 8x to the 15th, y to the 13th. Again, no adding, no subtracting, so go to your 6 lines, okay? Now, do you have a radical? You do. So you need to rewrite it as a quantity, parentheses, to the 1/3 power, and then you simply put 8x to the 15th, y to the 13th. So we have 8 times x times y. Okay, so 1 times 1/3 is 1/3. 15 times 1/3 is 5 whole. 13 times 1/3 is 4 1/3. So those are all positives, so they all just come over. Okay, where I have whole exponents, the 5 and the 4, those need to be listed first. Then the fractions, 1/3 with its base of 8, and then 1/3 with its base of y. Now, no bottom, no bottom, bottom, bottom. Now check your 3s and see if you can get rid of any of your bottoms. Well, I can with the 8 because that's on here, so it's 2. So cross that out and put a 2, and the top exponent's 1, so it will be 2 to the 1 power. Now that's no longer a fraction. y is not going to be on the list, so that stays. Now if I have nothing on bottom, I don't have to worry about that. Okay. Okay, whole exponents, drop those down, whole. If it's a whole, you don't mess with a radical. Y to the fourth, 2 to the 1, and then that bottom I was not able to get rid of, I get rid of it now and make a cubed root out of it. And inside you put y to the first. Okay, now 2 to the 1 can be simplified to 2, and then the variables would just stay the way they are. Okay, now in your radical, you don't have a number base, you just have the variable, so you don't have to do what you did here. Okay, it's just y to the first. Okay, next problem. Number 3, the square root, it's 2 square root, if you don't see it, of 12x times the square root of 14x. Now, I did not say plus or minus, so make your 6 lines. And you do have radicals. Fortunately, they are both the same, so we make it into one single quantity to the 1/2 power, because they're 2's now. So I take 12 times 14, that's 168, and then x times x is x to the 2nd power. So I have a base of 168 times x. And then a 1 times 1/2 is 1/2, 2 times 1/2 is 1 whole. They're both positive, so they both come over. Okay, now put the whole one first, x to the 1, and then the one with a fraction, 168 to the 1/2. That's a whole, don't circle anything. That has a bottom, circle the 2. Now look up your 2 list and see if 168 is on here. It is not, so the 2 stays for now. Delete that. Now that's a whole, so I just put it down. But this still has a 2, so I cross out the 2, make a radical 2, and inside I put 168 to the 1st power. So x to the 1st would stay the same, and then we make a radical 2, and we have the number base with its exponents. We need to try to simplify that, so it'd be 168. So we break it down. So 168, you'd start dividing at 144 and you get decimals all the way up to 4. Just to save time in the video, if I divide 168 by 4, you get 42. So it's 4 and 42. So that becomes a 2, so a 2 comes out to the front, and then 42 goes inside. Now, I wrote hints on the next 2 problems to help you, and those hints will be presented on the test. We have the square root of 10 times the 4th root of 10, okay? So, we are making our 6 lines to simplify it, because I never said plus, but when we equal it, because we do have radicals, you're going to have 2 separate parentheses, one with a 1/2 and one with a 1/4, okay? So 10 and 10. You cannot multiply the 10 and the 10 because one's in a square root, one's in a 4th root. Okay, so bases, I have 10 and 10. Well, I'm just going to write a 10 with a plus sign then. And 1 times 1/2 is 1/2. 1 times 1/4 is 1/4. So I take 1/2 plus 1/4 on a calculator, it would be 3/4. And it's positive, so the base 10 to the 3/4 stays in position. Now I bring that over, and the base has a fraction, so I quickly look up 4 to see if I can get rid of it quickly. No, it cannot, okay, because 10's not on here. Well, we don't have anything on bottom. Remember, this line's only used if you have bottom with fraction exponents, okay. Now we get rid of the 4 the quick way, then with a 4th root, and we make it 10 to the power of 3. So, I don't have any outside bases, so I got a 4th, and I have a number base of 10 to the 3rd. So we need to simplify that. So 10 to the 3rd is 1,000. Now see if it can break down. So it would be 1,000 divided by 625, doesn't work, 1.6. 1,000 divided by 256 doesn't work. 1,000 divided by 81 doesn't work, and 1,000 divided by 16 doesn't work. So what do we do if nothing works? Well, you just keep the 1,000 inside the radical, and that's the final answer. Okay. Next problem, we have that same hint. We have the cubed root of x to the 5th divided by the 4th root of x to the 3rd. So again, we need two separate parentheses. One's a 1/3 and the other is a 1/4. Okay. So we put x to the 5th inside this, x to the 3rd inside this. So we have a base x divided by a base x. So we don't plus them, we put one on top, one on bottom, we'll cross one of them out. So 5 times 1/3 is 1 2/3. 3 times 1/4 is 3/4. Now we cancel the x with the smaller exponent and subtract 3/4 from 1 2/3. And that's 11/12. So it's a positive 11/12. Okay, so I just have, it stays the same. Now, I don't even have a list for 12, and even if I did, the letter X would not be there. Don't need to use that one. Now we get rid of the 12 by making a 12th root, and x to the 11th. And then I'm pretty sure I can't simplify x to the 11th power. So that would be placed. Number 6, 27 to the negative 2/3 power. Never said plus, never said minus. Now, do we have a radical like this thing here? No, we don't. So don't try to write it equal to anything, okay? You start going. You got 27. 1 times negative 2/3 is negative 2/3. Now that needs to switch positions to the bottom so we can have a positive 2/3. Okay? So, this fraction's all you got, so bring it over. And remember to always circle the denominator of the rational exponent. Now you check your list. This is why you want to do that. The cubed root of 27 is 3, so this goes away, but the 27 turns into a 3 then. So we now have 3 to the 2nd power. Here, I'll write it off to the side. 3 to the 2nd. Now, we actually have a base on bottom, but the exponent is now a whole exponent. So I still don't need to do anything here. It's a whole 2. Now, that is a whole exponent, so I do not make a radical out of it. There is no bottom to the exponent. And then 3 to the 2nd is 9, and there would be a 1 over the top of it, 1/9. Okay, number 7. Y to the 1/8 times y to the 1/2. Never said plus, never said minus. And we will not be writing equal and making a, because there's no radical, we go with what we have. We have a y times a y, so that's a plus. So it's going to be 1/8 plus 1/2. 1/8 plus 1/2 is 5/8. Okay, so you bring the y to the 5/8 over. Okay, and it's fractions all you got. Now you want to circle the bottom. Obviously, I can't get rid of it. I don't have an 8th root list, and if I did, y wouldn't be there. Okay. So we don't have to do this because you have no bases on bottom. So we make an 8th root, and inside we put y to the 5th. Okay, so we make our 8th root, and I just have the letter base y to the 5th, and that's your final answer. Okay, number 8, 64 x to the 11th, y to the 9th. Okay, that's a 9 right there. Sorry. Okay. Over 125 x to the 2nd, y to the 18th with a 2/3 outside the parentheses. Now, again, no radical, so I do not write equals. Okay, I do not need to change this problem. So I have a base 64 and a base 125. Then I have base x on top and on bottom. Then I have base y on top and on bottom. So 64 to the 1. 1 times 2/3 is 2/3. Then 11 times 2/3 is 7 and 1/3. Okay. Then y, 9 times 1/3 is 6. 1 times 2/3 is 2/3. And then 2 times 2/3 is 1 and 1/3. Okay, 18 times 2/3 is 12. Okay, now you got some canceling to do. You cancel the 1 1/3 on the x and subtract 1 1/3, and that actually equals 6 whole. Then the 6 goes, and I minus 6 from 12, and that's going to be 6 whole on the bottom. Okay, so none of these switch positions. I mean, 64 to the 2/3 is positive, and so is the x to the 6. By positive, I mean the power. Then 125 to the 2/3 times y 6. Okay. Okay, so here's your holes. Bring them over. Then your fractions. So times 64 to the 2/3 power. Circle the bottom. And then 125 to the 2/3 power, because we got to do something with those bottoms. First thing I do is check my list, the 3 list. Well, 64 is here. It's equal to 4. Okay. So this is 4, and that 2, it's still to the 2 power. Okay. This 2 is on top. This that's 5, and that one's 5 to the 2 power. The 2 is still there. If you want to put it, that would be it. Okay, now I do have bases on bottom, but the 6 is a whole, and so is the 2 now. So they're both whole. I don't need to do anything there. Okay. Now, I don't think I need to make a radical because that has a whole exponent. That has a whole exponent. The 4 has a whole exponent. It's to the 2. And the 5 has a whole exponent. It's to the 2. Okay. All right, so I didn't need to make a radical. I got rid of all my bottoms the quick way. Okay, so now you simplify. That can be simplified to 16 times x to the 6th. And this guy here simplifies to 25 times y to the 6th. So there we have it. Okay, number 9. We have the cubed root of 2x divided by the cubed root of 3y. Make sure the denominator is rationalized. That means you will have to use this line here. Okay. Now, we're back to having radicals, so we need to write that as a parentheses then, and they're the same radical, so it's the whole thing's to the 1/3 power. Okay. Inside you have 2x, outside you have 3y. So on top you have a base 2, bottom a base 3, then an x, then a y. So 2, 1, 1 times 1/3 is 1/3. 1 times 1/3 is 1/3. 1 times 1/3 is 1/3. So basically it's all 1/3. So they all just come over here. 2 to the 1/3 times x to the 1/3. 3 to the 1/3 times y to the 1/3. Okay. You don't have any holes. All these exponents are fractions, so you just bring them over. But be circling the bottoms when you do that. Now, if you look at your 3 list, the 2 is not going to show up. Neither will the 3. Neither will the x. Neither will the y. So all the 3's have to stay. Now, we have to use this line because this is not a whole exponent. It's a rational exponent, and so is that. We need to make those into wholes. So the top I just write down. Okay. Now, the first base on bottom is a 3. That needs a whole exponent. So I write 3 to the 1/3. I make a 3 next to it, put a 3 on bottom. What's 3 minus 1? It would be 2. So I got to remember to times the top by 3 to the 2/3 power. Now I do that because now that makes the 3 on the bottom into a whole 1, because 1/3 plus 2/3 is 1. Now I do the same with the y. Okay. It'll be 2/3 again. Again, we do that so I can make the y to the 1. So whole, I have 3 to the whole 1 power and y to the whole 1. But I still have a lot of fractions on top. Okay, they all have a 3, so I make 1 cubed root out of this. Now you want to put your base number first, the 2 to the 1, and the other base number, the 3 to the 2. Okay. Then x to the 1 and y to the 2. Okay, so their outsides, it'll just be 3 times y to the first. Now you make your cubed root. Now circle your bases, okay? And you put your variables right here. Now what I do now is I make a cubed root, and I have to figure out what 2 to the first times 3 to the second is. It's really just 2 times 9, but I'll show you how I'm coming up with it. It's 18. Now I try to break down 18. 18 divided by 8 is a decimal, so I do not break it down. I just put 18 in there, and we are done with that horrendous problem. Okay. Now this goes a lot quicker, because 18 radical 3m square root of 3m minus 25 square root of 3m. I said minus, so that's a game changer. Make it plus negative, because when you have plus, you don't make the 6 lines. You underline the radical, and they're exactly the same, which is what they're supposed to be in order to add and subtract. Then you take 18 plus negative 25, and that's negative 7. Okay, easy there. Next problem. The square root of 75 plus 2 square root 48 plus negative 5 square root 3. So we see these pluses here. Okay, that's a game changer. But unlike the last problem, under the radical are all different expressions. So we make a table over here and we try to get them to match. So the square root of 75, 2 square root 48, negative 5 square root 3. So I'm on my 2 list, okay, so I make square root times square root. So I'd start dividing by 64, decimal, then 49, decimal, then 36, decimal, 25. Okay, I'm going to fill it in with 25 and 3, and that goes to 5. So 5 square root 3, I don't need to multiply because there was not a outside coefficient. So this is replaced with 5 square root 3 plus. Now I drop the 2 coefficient and put it times, and then do my 2 square roots. So 48 divided by 36, nope. Divided by 25, nope. Divided by 16, bingo. 16 and 3. So that turns into a 4. So we have 2 times 4 times the square root of 3. So that's 8 square root of 3. Okay, then negative 5 times square root times square root. Problem is 3 is too small to divide by anything, so I don't do this, and I just keep that the same. Now the insides all match, so I do what I did on the last problem. Write the radical and add the outsides. 5 plus 8 is 13, plus negative 5 is 8. Okay, this problem here, I'm going to write a hint on the test. Okay, I didn't on this. I will write FOIL, and I'm also going to make a little box here because negative 5 square root 32 can be broken down. Okay. You have to do that before you FOIL, okay? I will include that and that on the test, okay? So before you do a FOIL, you gotta make the 2, I'm not writing the 2 because 2 is too small to divide. So I'm gonna divide 32 by 25, doesn't work. By 16, boom, 16 and 2. So that turns into 4. So we have negative 5 times 4 times the square root of 2. So this is negative 20 square root 2. Now you need to rewrite the problem. So 3 plus 2 radical 2 times 8 plus negative 20 radical 2. Now you can FOIL. So you go 3 to 8, then 3 to negative 20, but make sure you put radical 2 on the 20. 2 to 8, 2 radical 2 times 8. Then 2 to negative 20, 2 radical 2 times negative 20 radical 2. So this is 24 simplified. This would be negative 60, and I put the square root of 2 next to it. That's simplified because 2 is not a perfect square. Then I take the 2 times the 8, that's 16, with a radical 2. That's good that we got radical 2 there. Then I take 2 times negative 20 is negative 40, but you got to multiply the 2 and the 2 now because they're both in a radical. That's 4. Now don't circle it because the square root of 4 is 2. So it's negative 40 times 2 is negative 80. Now we add 24 to negative 80, and that's negative 56. Then these radicals match, so I put radical 2, and I add the negative 60 to the 16, and that's going to be negative 44. Don't add these, okay? You can't. That has a radical, that doesn't, okay? Simplified. Okay, number 13, take these x squareds out of the problem. 4 square root 216 plus 3 square root 54. There's that plus sign, so don't make the 6 lines. Match up the insides with a table. So you drop your 4, and then you try to make it into 2. So you're on the square root, 216. Eventually you divide it by 36, okay? 36 and 6, okay? So this changes to a 6, 4 times 6. That'd be 24 square root 6. It's a 2, okay? Plus, now I drop my 3. 54, you'd start at 49. Eventually you would get up to 9. Remember, look at the 2 list, getting the 9 and 6. So this becomes 3, so we have 3 times the square root of 6. So it's going to be 9 square root 6. So I put my square root 6 down, and 24 plus 9 is 33. Now with the x squared, I will run this by you. If you have an x with a variable with a power, you can pull out the variable if you take the 2 divided by the 2, which would be 1. So it would be 4x, because x to the 1's x, and this would be 3x. So all that would happen is instead of 33, it would be 33x, but don't worry about that. Okay, now you're solving equations. So we've done 2 parts. Part 1's the multiplying, dividing with the 6 lines. Part 2 is trying to match the inside so we can add. Now part 3 is equation solving for x. So this is a 2, circle the radical. You don't have anything outside the radical, so you go to your 2 power. So I put a parentheses, and I put a 2 power, and I put a parentheses here with a 2 power. The 2 power and the radical cancel, and I just have 3x plus 3. But the side that did not have the radical, that's not just a number to a power, it's a binomial to a power, so we need to take the binomial times itself and apply the FOIL method. So x times x times 1, 1 times x, and 1 times 1. X to the second, 1x, 1x, so that's going to make us a 2x, and then a 1. So right over here, x to the second plus 2x plus 1. So this equation has 2 answers. We have x to the second. We've also got x. So when we have x second and x in the same equation, we have to apply our factoring properties. So you take out this side, because that doesn't have the x squared, so I minus 3x from the 2x, minus 3 from the 1. So we have x to the second, minus 1x, minus 2 equals 0. Now I factor the 3 terms, GCF and T. The GCF's 1, so you don't have to do it. 1 times negative 2 is negative 2, so we're talking a positive times a negative. They have to add to make negative 1, and 1 and 2 do that, okay? And that would be negative 1, too. The signs are like I want them, okay? So plus 1 minus 2, okay? Okay, now a is just 1x squared, so we can ditch the 1 and just use xx. We don't need this, okay? So we have x plus 1, x minus 2 equals 0. Okay, then x plus 1 could equal 0, x minus 2 could equal 0. So minus 1, you have negative 1, plus 2, you get 2. Okay, 15 goes much quicker. It's another radical equation, okay? Now the radical's over here. Now before you do the 2 power, you have an operation to get rid of. You need to minus 2 and then do your 2 power. Now this is going to be much quicker than the last one. So we minus 2 to get that, and that equals 2. Still got the square root of x plus 5. Now we do our 2 power. So that it cancels on this side and you have x plus 5, but guys, you got to take your 2 to the second. It's 4. Now this time there's just one answer, and that allows us to apply linear properties. That's where I just get rid of the operations around the x. So minus 5, 4 minus 5 is negative 1. Okay, number 14, or 16, 4 times the quantity x minus 2 to the 2/3 power equals 16. Now you can't take your 4 into there with the power here. So you are going to use your h rule. Remember, when you use the h, you need to bring back the x minus 2 expression. Now it's not guaranteed that we use this side, so I put question mark. So I have 4 times h to the 2/3 power equals 16. So I need to divide by 4 first. That would be 4. Now remember how to eliminate a rational fraction exponent. You simply raise each side to the reciprocal power 3/2. Now, we are going to be first looking at the 4 with the 2. Now this little 2 here is even, okay? So I'll be looking at an even list, which will mean we are going to keep both sides because it could be the positive or the negative. If that little number on bottom's odd, it's just that. So I look at 2, okay, 4's there, it's 2. So this becomes 2, but it still has its 3rd power, okay? 2 to the 3rd is 8. So you put 8 and negative 8. Here, I'll show it. And it's all, we're using both sides because that little number's even, okay? The square root of 4 is 2, but then it's 2 to the 3rd. So that's 10 and negative 6. Okay, now we're graphing radical equations. I will tell you on the test, you just have to graph square roots. So first, just put the radical over the x. It's a square root, okay? Actually, just don't even put the 2, because you're just going to be using the perfect squares, okay? And do your d and r over here. Okay, domain and range. So xy, you only want perfect squares. 1, 4, 9, no negative inputs. So it's going to be 3, 2, 1, 0. Now, do you have anything inside the radical that I just circled? No, you don't. That's a stay. But you got outside operations. Remember, the outsides have the same effect to the y. So we got times negative 2 and minus 3. Do them in that order. You got a times first, then minus. So 3 times negative 2 is negative 6. Minus 3 is negative 9. 2 times negative 2 is negative 4. Minus 3 is negative 7. And then you're going to go negative 5 and negative 3. It follows a pattern, okay? So if I would put 9 in here, the square root of 9 is 3. But negative 2 multiplied by 3 is negative 6. And then minus 3 is negative 9. So that works, okay? Okay, so on x, we can go by ones on both ways, but do your 0, negative 3 first, because that's your restriction point. Then 1, negative 5. Go down. 4, negative 7. 1, 2, 3, 4, 1, 2. And then 9, negative 9. Okay, and this keeps on rolling that way, but right there it's restricted, okay? Now, 2 ways you can do your domain and range. 0 is the x, negative 3 is the y, because it's based off that point. Now you can look at your table. All points are bigger than 0 for x, so this is greater than or equal to. All points after -3 go less than now, so it's less than. Or you can use a graph, okay? You split it into a right-left half. All points are to the right, so it's greater than or equal. Then I split it into two vertical halves at that point. From that point, both those lines should run through that point, and all points are under the line, so that's going to be below, so that results in a less than or equal to range. Or you can look at your table. Okay, 18, another square root, y equals square root x. So we know the setup, we should be getting that down good. So 0, no negatives, 1, 4, 9. So 3, 2, 1, 0. Okay, domain, range. Okay, so what's in the radical? A +4. Well, operations in the radical function do the opposite to the x. Now, you don't have any times operation, but you have a minus outside. That does the same to the y. So 9 minus 4 is 5, 4 minus 4 is 0, 1 minus 4 is -3, 0 minus 4 is -4. 3 minus 6, -3, -4, -5, -6. Okay. Again, we can roll by ones. -4, -6 is the last possible point this way. 1, 2, 3, 4. That's a restriction point. Mark it. 1, 2, 3, 1, 2, 3, 4, 5. Now it looks like it's trending up. Again. Okay, now -4, -6. Okay, it goes to the right, greater than or equal. Then, and it's above this time, okay, greater than or equal. Now you can tell because after -4, these points are bigger than -4. -6, these points are also bigger, so they're both greater.